And happy Friday. Right? I don't know that everybody will see this video on Friday, but it is Friday for those of you that are going to get this posted. And this is the set. This is what we are going to work on today. In class, pretty simple. It says create a standard mathematical representation, table graph equation that relates to the figure. So this is kind of exactly what we did in the notes. Don't feel you have to come up with the equations first, right? I always feel like I got to do that first and then fill in the table and the graph. No. We don't have to do that, right? What we can do is we can go ahead and we can fill in the table first and the graph and utilize that information to help us come back and create the equations. So whether you see what's going on, oops, not there. Whether you see what's going on from here to here and here to here, if you look at it that way, that's fine. Or I'm just going to go ahead and count the number of boxes in each figure. 3 in the first figure, 2, 4, 6, 8, 10. And then we got 3 by 1, 2, 3, 4, 5, 6, 7. 7 times 3 is 21. So 21, that's kind of how I counted them just relatively quickly. A little bit of multiplication there. So 3 to 10, how do I get there? 10 to 21, that's plus 7. That would be plus 11. So we kind of see what's going on here. And I don't have a third, another figure, that would be plus 4. So I'm looking at this as there's no common difference, first difference. There is a second difference, and I could also utilize that in my table, all right? So this would be figure number. This would be number of boxes, and I pretty much have the table filled out already. 1, 2, 3, 4. In figure number 1, we had 3. In figure number 2, we had 10 and then 21. So 10 down here. We had 21. And this is going to help me figure out how many are in box 4. We should be able to do this with the three pieces of information. We should be able to do this. That was plus 7. This is plus 11. So what's the difference of 7 and 11? That's plus 4. Hey, 7, 11. All of a sudden, why do I want to go get a cold drink? So that should be another plus 4. 11 plus 4 should be plus 15. So 5 plus 1 is 6. 2 plus 1 is 3. So there should be 36 boxes in the fourth figure if we're doing that correctly. Now we need to fill out the graph. How am I going to fill out the graph? Well, they leave it blank on purpose because they want you to be able to fill out the graph the way you want to be able to do it. So what we're going to discuss is, hey, here's my figure number. And my figure numbers increased by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're not going to need all those. And then what should go on the y-axis? The y-axis should be my output here, which is going to be my number of boxes. Okay? Now, how do I increase my number of boxes? Do I increase my number of boxes by units of 1, units of 5, 10, 20, 30, 50? What do I do? Well, look at where you start. Look at your first value and look at where you stop. I start at 3 and stop at 36, but I know it's going to go much higher than that. Box number 5, that's going to be plus 15 plus what? 15 and 4 is plus 19, so it's going to increase quite a bit. So let's just go ahead and skip a line. Well, let's see if 10, 20, 30, 40, 50, 60, and 70. We can get 70 in there. That's probably going to be decent enough. If if this was an exponential function, I'd probably say each line is 10. But I can say each line is 5 because it's quadratic. How do I know it's quadratic? Right here, second difference. All right? That's how I know. So just plot your points. So pause it and see how you do. So 1 is 3, that's going to be right here. 2 is 10. 3 is 21, just above 20. 4 is 36, so 30, 35, 36. And I can use this to help predict how many boxes are going to be in 5. And it's probably going to be 65 or so, 50, somewhere around in there. That's how I can predict that. It's not asking us to do that, but that's what. All right, so we got the table and the graph figured out. Now we need to go back and figure out the equation. So we just need to figure out kind of what's going on here. This is the tough part. I'm going to tell you. This is difficult. I struggle with this stuff as well, as most of you will. So if you struggle with explicit equations, take comfort in knowing that you're not alone. Okay, this is a tough thing. You have to look at the diagram and see a pattern that's going on. What type of pattern is happening? Well, if I concentrate just on the first, the first box right here, okay? I'm going to concentrate on that, and I'm going to look at this and say, how can I represent the area of that first box? I can represent the area of it as 1 by 1. Okay? Now, what else is happening? Well, there's 1 by 1. I could say 1 by 1 plus 2. Is that going to work for me every time? Is my second figure going to be 2 by 2 plus 2? Well, here would be 2 by 2, but I have more than 2 at the end. Here would be 3 by 3, and I have more than 3 at the end, because 1 by 1, that's the same number times the same number, and then plus 2 should always be plus 2. I'm just kind of going through my brain to try and figure things out here. Right? How can I figure out what is happening here? Well, wait a second. I see one perfect square. I see a second perfect square, possibly a third perfect square. Jump over to my next figure. One perfect square, two perfect squares, plus a couple more. One perfect square, plus a second perfect square, plus some more. And then it's, if I go with that thought, it's plus 1, plus 2, plus 3, which is the same as my figure number. So this over here should be 2 4x4s plus 4 on the end. That's kind of how I would see that. Hey, that works. How do I find the area of one figure? The area of one figure is 1 by 1. I got to double that area because I have 2 of them. I have 2 perfect squares, and it's plus 1. This is 2 by 2 plus 2. This is 3 by 3 plus 3. What's happening here? I'm taking my area, so if I want to make an equation here, I'm going to take the area of any given figure, n by n, and I'm going to add that figure. I got to multiply n by n first, okay? And I'm going to double that. I should be able to double that. So what that's going to do, sorry, phone's ringing. I'm not going to answer it. I'm just going to see who it is so I can call him back. I figured that's who it was. We're going to finish this up real quick and we're going to be done. So this should be n by n is what it should end up being, plus n. So this gives me n by n is n squared. So 2n squared plus n. Let's see if this works. Let's just test it with a couple of points. I'm going to plug 1 in here. Okay, so 1 squared is 1. 1 times 2 is 2. 2 plus 1 is 3. Works. Okay, again, I got to test my hypothesis, not just once, but a couple of times. Figure number 2. 2 squared is 4. 4 times 2 is 8. 8 plus 2 is 10. Hey, it works. I'm pretty sure that right there, that's my explicit formula. Again, those are hard. Those are hard. Okay, so we have the explicit formula, explicit equation. We'll just put exp right there. The recursive is going to look a lot like this. Okay, recursive is going to be f of 1 is equal to 3. F of x is equal to f of x minus 1 plus 4x minus 1. There's going to be your recursive. Because remember, if it's a quadratic, this second part right here, go back and look on page 3 and 4. For quadratic, that second part is going to be in the form, it's going to be linear. That relationship is going to be linear. We can talk more about that later. Sum this up real quick. How does the rate of change of the relationship and the problem show up in the table? You should be able to explain that. Okay? I'm not going to write it down, but if you're paying attention to the video, it's second differences. And how do the terms and the equations connect with the diagrams? Basically, again, listen, put this in your own words. The terms and the equations connect with the diagrams because I am basically grouping it in areas of perfect squares. There's 2 perfect squares plus the figure number, or there's extra added on, which happens to be the number of the figures. So however you word that in your sentence, make sure you get that filled in.